Hello everyone, today we're going to talk about what OSPF is and how it works. So have you ever heard of OSPF? It's actually a type of dynamic routing protocol. How is it different from the static routing we talked about before? With static routing, if we want to configure it, we have to set it up on each device. We have to manually specify the route for each one, telling it exactly how to get there. And during this process, after I've specified the route, we also need to consider the return path. Moreover, with static routing, for example, if a failure occurs between nodes 3 and 5, not on their directly connected link, it can't automatically detect the problem, nor can it switch routes on its own. But our OSPF is different. OSPF can automatically calculate the optimal path during this process, and if a problem occurs at the remote end, it can also detect it automatically and switch routes accordingly. In medium and large enterprises, we often use the OSPF routing protocol. So today, let's first talk about how to configure it. Before configuring OSPF, we first need to access our device and set up its view. If during this process we open R1, then while we're in the configuration view, the first step is to create the OSPF process. If we're using Cisco here, we need to enter router OSPF during this process. After that, we need to input the OSPF process ID. For the device, if it wants to enable a certain function, it needs to create the corresponding process. It's similar to how on our computers, if we want to use a social media app, we need to download that application onto our computer or phone. So in this process, after entering the OSPF process, we need to make announcements. Here, announcement has two layers of meaning because OSPF is a routing protocol with social attributes. What does it mean to have social attributes? It means that it can establish neighbor relationships with other devices. So if I have any routes I want to share, I can send them to my neighbors. So here, when we talk about making announcements, the network announcement we just mentioned refers to first announcing directly connected networks. For example, if I am 12.12.12.0 and you are also 12.12.12.0, we are directly connected, so we will establish a neighbor relationship. Secondly, if I have any routes on my device that I want to tell you about, I need to make an additional announcement. Now, in this process, on R1, we announce the network. During this process, we declare the 1.1.1.0 network on my device. And here we also need to pay attention to the fact that OSPF announcements are followed by a wildcard mask. What is anti-salt code? Normally, the subnet mask should be 255.255.2555.0. So what about the wildcard mask? We need 0.0.0.25 so that I can make a declaration. And in this process, if we just announce it directly like this, it will tell us that it failed because we also need to specify an area after it. Each area is responsible for its own affairs. In this process, most of the time we set it as the backbone area, which is area 0. Apart from area 0, all the other areas are called non-backbone areas. Here, we only need to announce 1.1.0.0. As for our R, we also need to create a process here and then make the announcement. It has 3 interfaces, and these 3 interfaces are each connected to 3 devices. We need to announce all 3 of these interfaces. Now let's move on to device number 2. First, it's the same here. Use router EC OSPF1 to create the OSPF process. Then during this process, use network 1.2.1.0.0.0.255 area 0. And during this process, you also need to announce another network 2.3.1.0.0.0.0.255 area 0. In addition to this, we also need to add another network on the network 3.4. 4.1.1.0, 0.0.0.255, area 0. In other words, each device actually needs to perform this same operation. Now, for each device here, we need to enter its OSPF process and create a process for it. After creating the process, we It will automatically enter this process, and then we execute the command to declare the network 23.1.0.0.0.0.255. After everything is set up, in the future it will use OSPF to exchange routes with its neighbors. It will automatically learn and calculate routes, so we don't need to manage it manually anymore. In this process, if we want the other party to learn this route, we need to make a series of announcements to them. After finishing the configuration on device 3, we will move on to configure device 4. For device 4, the process is the same. We need to create an OSPF process, router OSPF 1. During this process, we configure the network statements, network 24.1.1.0, 0.0.0.255 area 0, and within this, network 45.1.1.0, 0.0.0.255 area 0. Then we move on to device 5. On device 5, in addition to connecting to devices 3 and 4, I also want the other side to learn about my 5.5.5.5 address. So in this process, we also need to announce this 5.5.5.5 address. Since this address is 32 bits, when we announce it, we can use 0.0.0.0 as the wildcard mask. So here we announce it into area 0. Then for the network statements, network 35.1.1.5, 35.1.1.0, 0.0.0.255 area 0. In addition to this, we also have network 45.1.1.01, 0.0.0.255 area 0. Now at this point, we've completed all the configurations. If in the future you want to check whether OSPF neighbors have been established, you need to use the show IP OSPF neighbor command to view this information. For example, on our R device, if we want to check, since we're in configuration mode, we need to add do before the command. Do show IP OSPF, then we add neighbor. Now during this process, if in the future when we check again, we find that there's a problem, we can exit the current configuration mode. In other words, this configuration mode can't be used, and we can identify this through the error message. So in this process, how do we exit? We need to use end. After exiting with end, we can then use show IP OSPF neighbor to check the status. Now you can see that on R2 it has established 3 neighbors. One of them is 45.1.1.24, which is R4, and the others are R3 and R1. All these neighbors have been successfully established. If the state is full, it means the adjacency has been successfully formed. Now let's take a look on R5. On R5, during this process, we also need to enter privileged mode and check with show IP OSPF neighbor. At this point, R5, R4, and R3 have all become neighbors with R4. So in the future, will I be able to ping R5 from R1? Alright, at this point, let's use R1 to ping 5.5.5.5 and see what happens. Since we're currently in configuration mode, we need to add a do command. So do ping 5.5.5.5. Now we can see that communication is working properly. If we want to check our routing table in the future, we can use do show IP route. Now during this process, we can see that routes like 5.5.5.5 as well as 45.1.1.0 and similar routes have all been learned through OSPF. So this is something you need to understand during this process. In our enterprises, we often use the OSPF routing protocol as well. If you want to learn more about networking in the future, not just Cisco knowledge, but also Huawei knowledge, feel free to send me a private message or leave a comment below the video for technical discussions.